Yeah, I'll finish it next hour. Okay, we're going to start at 10D. Guys, we're started back. Please be quiet. In the circle at the right, AB is a diameter. That's great. So that means it goes through the center. It's a diameter, and the measure of arc DC is 100 degrees. So this arc is 100 degrees here. What is the measure of angle DEC? Gentlemen. So I'm trying to find this measure of this angle here, and let's just call it X. So what's the measure of that angle X? Now, we've talked about these. These are two chords intersecting inside. Two chords intersecting inside a circle. What do we know about A, B, and C when they intersect inside? B is obviously going to be bigger than A, and C is in the middle. What do we know about those three? What formula can we use? Not a right triangle. Okay, do you guys have your circles packet that we studied? Ow is when we're looking at, if we're looking at links is when we use ow. Okay, you guys are on the right thing. You got A minus B divided by 2 or A plus B divided by 2. Now the question is it minus or is it plus? Look at both of these arcs. Are these normal arcs or are they negative arcs? They both look like a slice of pizza, right? So that means they're normal arcs. So they're both going to be positive. So a positive A and a positive B divided by 2 should equal the C. Now in a minute, if we looked at this, let's see. Here, we have what looks like a normal arc on the right, but an inverted or negative arc on the left, and that's when we use the A minus B over 2. Okay, so utilizing this, A plus B over 2, let's figure out what these A and B are in this case over here. So we see that one of them is 100 degrees. Okay, but we still don't know the other two. Could we figure out what one of those other two arc measures or angle measures are? Say again. Do I know how much this angle that's in red is or this angle is? They are the same as each other, but I don't know how much they are. Do I know how much this is? 180. That's 180 because this was a diameter. So that's 180 degrees. So now I can use my formula and I can say X instead of C equals 180 plus 100 divided by 2. So X equals 280 over 2, which is equal to 140 degrees. So X is 140 degrees. That's what X was, the red angle here in the middle. 140. So the measure of angle DEC equals 140 degrees. Yes. The angle in the center will be the average of the two arcs. And it's when it's outside, like the blue one down here, then it's the average of the two arcs, but one of those arcs is a negative number. Yes, ma'am.
So it was a central angle, whatever shouldn't angle DEC be congruent to arc DC?
If it was a central angle, then yes, but it's not a central angle. How's it not a central angle? Because the angle is not formed at the center. It is formed inside the circle, but it's not at the center of the circle. This would be a central angle, like that. But this one is not formed at the center of the circle. Okay, so let's move on to the next one. Are we out of time? I can try to do this one in that time. Okay, find the measure of the angles in the pictures. So, what kind of angle? Now, you know what? Since we're there, 10F. 10F is easy. What kind of angle is this? That's a central angle. And the central angle is always equal to the arc. So x equals 124 degrees. Now, what kind of angle is this one?
No idea.
It's written on the circle, so it's called scribe means to write, right? So it's inscribed. It's written in the circle, written on the circle. Okay, so x is going to equal 80 divided by 2. It's still just the average, but it's the average of 80. And what's the angle? What's the measure of the arc here? How much arc? Yeah, there's 0 degrees there, right? So it's 80 plus 0 divided by 2. So it's 40. That's it. All right, I will finish recording this during next class. The day you take the test. We are back doing 10G in circles. Now, in the previous problems, we talked about how in this scenario here, you would add the two arcs and divide by 2. Basically, you're going to find the average of the two arcs would give you x. So in problem 10H, I'm going to have C equals A plus B over 2, where C is the angle C. And in this case, we're going to use X for the measure of angle C. And we're going to use 126 plus 84 for A and B divided by 2. Add those together, 126 plus 4 is 130, plus 80 is 210 divided by 2, that's degrees. I didn't put my degrees in there. 210 divided by 2 degrees, so x is equal to 105 degrees. 105 degrees, which is halfway between 84 and 126, or the average of the two. Okay, if we come back over here, though, to 10G, it's the same thing. But we got one problem. Over here, this looks like a slice of pizza, and this looks like a slice of pizza, because the arcs are oriented in a convex fashion to the central angle. They look like slices of pizzas or sectors of circles. So those are positive arcs. But over here, this one is still a positive arc. It's convex. But the green one is non-convex anymore. It is concave compared to this angle right here. It is like a concave. Yes, ma'am. I will not give you the formulas on the semester test. I don't believe these are on the I don't believe these are on the geometry end of course formula sheet, which is the only formula sheet we use on the semester test. It's the standard one that we're going to use, but these are not on there. So you're going to have to know. And that's why I try to focus less on memorizing this formula and more on memorizing the idea that you average the two to find the center one. And here you're going to average them, except 56 is on an inverted arc, so that makes it a negative whenever I average it. So this is going to be, or if you want to think of it as, If you want to think of it as b minus a, that is fine. When it intersects outside, it's b minus a. This is the formula that most of your teachers will tell you. When it intersects outside, it is b minus a. I try to find one way to think about this for every scenario, and the idea of the average works for every scenario, as long as you remember that an inverted arc will be negative. Okay? So in this case, either way you work it, you're going to end up getting that x is equal to 120 minus 56. Either you memorized this formula or you used a negative 56 in this formula. Either way, you're going to get a negative in front of that 56. And 120 minus 56, 120 minus 50 is 70, minus 6 is 64. And 64 divided by 2, that's 64 degrees, by the way. 64 degrees divided by 2 is 32 degrees, which is your answer. Okay. And remember, these are going to be online, so you can, if you didn't get something, you can go catch up online with these. All right, now are we dealing with arcs in this case right here? Are these arcs, arc measures? No, these are the lengths. So now we got to go back to the idea of lengths. We had two basic ideas that we were working here. We had ow equals ow, and then we had A1, A2 equals B1, B2. You might call it AB equals CD. It's fine, but you just have to remember where A, B, and C, and D are. That's why I don't like that. I like the A1, A2 because that tells you, hey, they're both part of the same A. B1 and B2 are both part of the same B. So which one goes with which? Does ow go with the inside, or does ow go with the intersection outside? Which one does it sound like it goes with? Outside, right? Ows goes with the outside intersections. So if we have an intersection of secants and tangents, or tangents and tangents, or two secants, if we have anything that intersects outside, it's going to be ow. If we have anything that intersects inside, we are going to use this A1, A2 equals B1, B2. Now this is times in between these. All these have times in between them. So let's look at A1, A2 first. When I say A1, A2, I'm talking about two parts of the same line. They're both parts of A. So what two numbers up here would be parts of the same line? 3 and 8. Good, we could call that A1 and A2. So A1 times A2 equals B1 times B2. A1 and A2 are parts of the same line, so 3 and 8 equals, now what's B1 and B2 going to be? 2 and x. Divide both sides by 2, and that reduces to 1. Divide this by 2, and that's going to reduce to 4. 3 times 4 is 12, which equals x. Yeah, I know, the dividing part's where everybody gets lost with me. So divide 2 by 2 here, and divide 8 by 2 here, and I get 4. Same thing though, right? 24 divided by 2. So I was asked, why can't I do 3 times 8 and get 24 divided by 2, and that's 12. That is true as well. It is true as well. But what's easier? It depends on what you learn. I think multiplying 3 times 4 to get 12 is easier than 24 divided by 2. It really shows up later on if you get bigger numbers. It shows up later on when you get bigger numbers. Okay. So now we need to do ow. So let's do ow here. In the case of tangents, I can do ow and say, what's the outside of the tangent 3x squared plus 18? What's the outside of it? How much of that is outside? 3x squared plus 18. And what's the whole length? So the outside was 3x squared plus 18. What's the whole length of that? 3x squared plus 18. Okay? And what's the outside of 2x squared plus 27? Right, so we're going to see something very similar. Okay. What's 5 times 5? What's another way to say that? 5 squared. What's x times x? What's dog times dog? So 5 times 5 is 5 squared. X times x is x squared. Dog times dog is dog squared. 3x squared plus 18 times 3x squared plus 18 is what? And what about the next one? 2x squared plus 27 squared. Since both of these things are squared, I can take the square root of both sides. And I just end up getting 3x squared plus 18 equals 2x squared plus 27. Now, I'm going to go ahead and tell you this works every single time, even though we've already talked about this. With two tangents like these are, they are tangents because they only hit the circle once. With two tangents, look at this bottom equation and look at the picture and tell me what you would tell somebody in shorthand. What would you do with this picture to get that bottom equation? If you wanted to skip all of this right here, what would you tell somebody to do? Just set them equal to each other, right? These two right here are equal to each other because they're both tangents through the same point. Okay? Because the outside and the whole will be the same thing. It doesn't matter what it is. You're always going to get something squared equals something squared. Then you can square root both sides. And basically, you're just going to get that these two tangents are equal to each other. Okay, I'm going to erase over here so that I can work this. So 3x squared plus 18 equals 2x squared plus 27. And to solve this, I'm going to subtract 18 from both sides. And divide or subtract 2x squared from both sides. And what should I do to solve this now? Square root both sides. So x equals positive or negative 3. So which one is it? Is it positive or negative, or is it both? Well, x is not linked on its own. I think you probably need to test both of them and figure out which one it is. Okay? Because it could be the positive or the negative. So we need to go back and look at our original work up here. In 3x squared plus 18, if I plug in a positive 3, then I'm going to get 27. Is 27 a valid number for this? Is 27 a valid number for this? Yes. All right, let's try that with 2x squared plus 17. Sorry, plus 27. So this is going to be 2 times 9. What's 2 times 9? Oh gosh, guys, look where I made a mistake here. This was 3 squared. 3 squared. Man, Mr. Conaway. All right, so 3 squared, that's going to be 3 times 9, which is going to be 27 plus 18 equals, what is 27 plus 18? 45. Okay, and here I'm going to get 18 plus 27 equals 45. Both of those, that one works, right? You got 45 for the length of both of those lines. So we know that positive 3 works. Does that mean negative 3 won't work? Let's find out what happens with a negative. I'm just going to use what they've got here. So plug in a negative here. What's negative 3 when I square it? Is it positive 9? That's right. And this here, if I put in a negative, I'm going to get positive 9. So positive and negative both work. Here's the situation I told you guys to be careful of. Everybody says the square root of 9 is 3. But you have to take into consideration that negative 3 could work too. So the answer is x equals positive or negative 3. Either one of them would work. Okay. And, you know, I'm going to go ahead and, well, let's see. What do I have? Do I have just this 2? I guess since I've just got these 2, I will finish working them out. We're just kind of long on this recording. Okay, is this going to be ow, or is it going to be AA equals BB? Yeah. This is going to be ow for both of them because they both intersect outside. Okay, they both intersect outside. Now, this one is actually going to get long. One of these is going to get long. Okay? One of these is going to get long. Man, I almost need to start this thing over. Let me just see it. Yeah, I'm going to start it over.